Okay, hello everyone. Okay, today the purpose of this video is to explain to you how to answer the questions for your Amali physics paper. Okay, so which is the kertas tiga. Okay, so I hope that this video is only shared among the students in HEBB. Okay, because how to say this is for you all only. Okay, it's not for us for the students outside from HEBB. Okay, so today I will explain to you about the how to answer the questions for kertas tiga Amali physics. Okay, so basically for Amali, okay, there are two types of questions. Okay, one is guided and one is unguided. Okay, for last year's SPM, okay, we realized that all physics, chemistry, and bio, all the three subjects, they came out guided questions. Okay, usually, okay, the last time when we got the format, okay, it stated that is two guided questions and one unguided. We don't know which subject is belongs to guided, which subject is belongs to unguided. However, for last year's, based on the what we had last year, all the three cap questions came out is guided. Okay, so today I will focus on how to answer the questions for the guided question. How to answer the guided questions first. Okay, for unguided, I think after you know how to answer the guided questions, okay, you will more or less able to answer the unguided questions already. Okay, so guided questions, the format is that, okay, they will give you everything. What you need to do is you just follow the steps to carry out the experiment. Then after that, you got the data already, you will be required to draw a graph, okay, calculate out the gradient or to identify some values based on the gradient, and also to identify or to explain the relationships, okay, between the two variables you have drawn on the graph. Okay, so and also they will ask you, sometimes they will ask you the precautions, and also they will ask you to predict, okay, if let's say something is added to the experiment, what will happen to the readings. Okay, so either it will be increased, decrease, or no change. So these are the predictions. Okay, so all these questions will be included in the guided questions. Okay, so here I will share you two samples, okay, of the guided questions. Okay, so please wait me for a while. Yeah. Okay, just a moment. Let me open it first. Okay, so these are this is the first guided questions that I would like to share to you. Okay, so as you can see here, okay, they will give you the instructions. Or say you are not allowed to work with the apparatus in the first 15 minutes. Okay, as you know, you will be given 5 minutes for each subject to check your apparatus. Okay, you will be given 3 trays altogether. Okay, 1 tray is for 1 subject. Okay, so 1 subject given 5 minutes. That's why here you will be given, where is it now? Okay, you will be given 15 minutes. Okay, 15 minutes, okay, to check the apparatus. So this period is used to check the apparatus list, read the questions, and plan the experiment which will be carried out. So which means that for this time, for this trial Amali, okay, you will be given 1 hour, 2 hour and 2 hours and 15 minutes to carry out the experiment. You can choose whether to start with bio, to start with chemistry, or to start with physics. It's up to you. Okay, you can choose which experiment to do first. Okay, based on your preference. Okay, maybe you think that okay, physics is much easier than the other two subjects. You can start with physics first. Okay, so same goes to chemistry and bio. Okay, so then you can mark okay in the box provided to check the material and the apparatus prepared and supplied. Okay, so all these are the what we call as the experiment. Okay, sorry. Okay, so this is what I have done during the one kursus. Okay, so I have taken everything that I have here. Okay, so these are the instructions. Okay, you read the first statement here that you are required to carry out experiment, okay, to investigate, okay, the relationship. Okay, to draw, okay, to state the relationship between, okay, between mass of the water and the extension of the rubber band. Okay, the one that I highlighted here is actually what we call as the variables. Yeah. Yeah, sorry, yeah. Okay, so between the mass of the water and the extension of the rubber, okay, rubber band. So this is what we call as the variables. Okay, sorry, I give you the spring first. Okay, these are the variables. Okay, so the variables, these two variables can be either MV or RV. Okay, they will not be arranged like the relationship between MV and RV. Sometimes they will interchange. So you have to identify yourself. Which one is the MV, which one is the RV. But definitely these two is either one of them. Okay, so if you look at the diagram, okay, if you look at the diagram here, okay, these are the diagram, okay, you will need to follow exactly, okay, the procedure, okay, they have given to you to carry out the experiment. Okay, sometimes the experiment is not exactly what you have done during the experiment, okay, we have done before, or following the textbook. So what you need to remember every time when you are doing the amali is that always follow the questions. Question asks you to do what, you do what. Follow, follow, follow. Okay, so you arrange it, okay, measure the initial length, okay, they ask you to measure like this, so you follow it. Okay, so from here, okay, they ask you to fill up 100 grams of the water into the empty bottle and record the length of the rubber band. Okay, so from this part, you are able to identify which one is your MV, which one is your RV. So if you read carefully, you will realize that the one that they have given you the value, which is the mass of the water. Okay, they have given you the value. Given value, this variable, it will be the manipulated variable. Okay, then the one that they ask you to read the result, record the result, which is here is record the length of the rubber band. This is your RV. Okay, so remember, read the questions carefully. If the questions they have given you the value, okay, the variables is MV. The one that they ask you to measure is the RV. Okay, how about, then you ask teacher, which one is your CV? Okay, constant variable, or we say is the fixed variable. Sometimes they will say is fixed variable. Okay, remember, for all the variables, okay, your apparatus cannot be your variables. Like for example, sometimes you all like to write the size of the measuring cylinder, the size of the bottle. No, cannot use that as your variables because that is the apparatus. Okay, sometimes some of you will write the type of the ruler. No, not at all. All the apparatus, okay, is not your fixed variable. Okay, so if you look at the diagram here, if you look at the diagram here, okay, you can write about, okay, the density of the water, okay, the density of the water, okay, then you can write about the type of the rubber band, okay, the type of the rubber band, okay, type of rubber band can, okay, because here we use different type of rubber band, it may affect your readings as well, okay, can I? Okay, so usually first questions they will ask you, okay, to identify the variables, okay, so as I said, you just copy the one that you have done, I mean the one that previously in your first statement here, okay, the relationship between the mass of the water and the extension, as I said before, this either one of it is your variables. So we have identified that mass of the water is the manipulated variable. So I write here directly. Follow the questions. The questions, write what, you just write what. And usually for my practice, okay, I will ask, okay, I would prefer you to write down the symbol of the variables as well. Okay, if you can, you write it down. If you cannot, it's okay. Okay, yeah. Then next, the responding variable, okay, the extension of the rubber band. As I said before, follow the questions as will do. Okay, then same, follow the questions. Okay, they ask you to calculate the extension of the rubber band by using the equation below for each length. Okay, x equals to L minus LO. LO is the initial length. Okay, so tabulate, okay, the value. As long as you see the word tabulate, which means that, okay, once you see the word tabulate, which means that your answer must be in table form. Okay, I know some of you, you like to just write the value as in like an invisible table. Hello, everyone. You have to use pencil and ruler, long ruler, to draw the table out. Please, okay, this is very important. Okay, no table, your marks will be deducted. Okay, so in this here, okay, it says that tabulate the value of L and X for each M, which means that the inside your table actually they will have three values for you to tabulate: L, M, L, X, and M. Okay, so usually this for each value, this will be the first column. Then this is the second column, and this will be the last column. Okay, follow it. So in your table, the most importantly, your first row must be the symbol with the unit. Symbol, unit, symbol, unit. You see, very clear and simple. Okay, that's why the previous one, I asked you in the variables that to write down the symbol so that you know that, oh, this symbol is belongs to MV. This symbol is belongs to RV. Because after that, it will help you to have the continuous, okay? Continuous, so that when you are drawing the graph, you will not be mistakenly which one is your y-axis, which one is your x-axis. Okay, so after that, you write down the values, okay, in the table. Okay, so in your table, most importantly is the value is the consistency. What is the meaning of consistency here is that the decimal places. Okay, for example, the M, the mass here. If let's say all the values here, there is no decimal place, or don't write any decimal place. Okay, if let's say L, there is one decimal place, like 0.5 here. The rest, you have to make it into one decimal place. I remember this, I have mentioned it when we are doing the experiment each and every time. Okay, so your x here, okay, if let's say one decimal place, the others also please make it into one decimal place. Okay, and so this is the tabulation. Okay, the tabulation is most important. First, you have to draw the table. Second, your first row, okay, is your symbol and unit. Okay, the third one, it will be the consistency, which is the decimal place. Each and every column, the decimal place must be the same. Okay? Okay, next. Okay, so all the experiment for physics, sure, they will ask you to draw a graph. Okay, so they will tell you on this graph, okay, plot a graph of x against m. So the one before against is your y-axis. The one after against is your x-axis. Actually, it does make sense, okay? If let's say you are, I mean, this is just a logical sharing that I want to share to you so that you feel that, okay, it's logical why the one before is y-axis, the one again after against is the x-axis. As you know, when you are looking for a coordinates, okay, when you are looking for a coordinates on a graph, you sure you will start with the x-axis, then only followed by y-axis, right? Okay, same goes to when you are drawing a physics graph. Okay, so manipulated variable is the 超中心变数, the one that you are changing. Okay, then responding variable 反应性变数 is the one that you got. So you must have the x-axis, then only you get the y-axis. That's why the one against, before against is your y-axis, which is your RV. The one after against is your x-axis, which is your m. Okay, please remember here. Okay, so when we are talking about the graph, okay, okay, so this is the graph that I have drawn here. Okay, you see, okay, I think I make it smaller for you to see clearly. Sorry, the drawing, the reading is not very clear. Okay. Okay, so first thing, on the graph there, you no need to write about the title. Okay, the title is not important. The most important is your graph. Okay, so first, okay, they will have 7 ticks here to give you, okay, in order for you to get full marks, 3 marks. Okay, so the first mark goes to your axis. Okay, the label and the unit of your axis. So you must label all correct to get the first tick and the second tick. Okay, so for the third tick, it will be your axis scale, which means that your x-axis scale and your y-axis scale. So remember, for physics, there is no heartbeat on your graph. Okay, you cannot then this one 5, 6, 7, 8 like that. No, cannot. You must be consistent. Okay, so over here you will start with 0. Then based on your reading, okay, like reading just now is I think you have to see the range lah. Okay, then you plan out the graph. Okay, here it will be 2, 4, 6, 8, 10, 12, 14, 16, 18. Synchronized and consistent. Okay, no need to draw the small line on the scale. That no need. You just write the number will do. Okay, then for your x-axis, 100, 200, 300, 400, and 500. Okay, so for your scale, okay, the value that you can use is either 1, 2, 5, 4, or 5. So meaning that if let's say here you put 1, 1, 2, 3, 4, 5, 6, 7, 8, or 2, like the one that I'm drawing here, 4 is like 4, 8, 12, 16, okay? You also can use that. Or 5. 5 is 5, 10, 15, okay? Not this value only lah. You can like just make it like 0 0.5, 1 like that. Okay, so as long as the scale is following these numbers, okay, then you are on the correct path. Okay, number 4 is you plot 3 points correctly based on your readings. Okay, take 5, plot another 2 points correctly. Okay, take 6, it will be the best fit line. Okay, it will be the best fit line. So you can see here that, okay, this is my best fit line. I have passes through 3 points, 1 point on top and 1 point at the bottom. As I said before, what is the best fit line? It's the line that can distribute the points that are not connected on the lines distributed equally. So this, my line here is the best fit line because I have 1 point up and 1 point down, and with the 3 points that is connected on the lines here. Okay, and the last thing will be your graph must be more than 50%, occupy more than 50% of the graph paper. Okay, that's why I always say your graph must draw as big as possible. So you have to plan out the which scale that you have to use in your graph. Okay, so this is how you draw out the graph. Okay, so with usually the graph given will be 3 marks. Okay, so if let's say you got 7 ticks, so you get 3 marks. 5 to 6 ticks, it will be 2 marks if I'm not mistaken. Later I will let you see another sample. I will let you see clearer. Okay. Okay, so and after that, they will ask you, okay, based on your graph, state the relationship between X and M. So you have to base on your own graph. Sometimes you say, oh, teacher, like for example, the Hooke's law, we know that the concept is directly proportional, but here the questions have stated is based on your graph. So you have to base on your graph that you have drawn to identify the, what do you call, the relationship. As you can see here, my graph, I didn't pass through the origin. I didn't pass through the origin here. I cut the x-axis. So whether either cut x-axis or cut y-axis, the relationship, it will still be increasing linearly. Okay, if let's say it cuts at the origin, which means that at 0, the answer, it will be directly proportional. Okay, so if let's say it cuts down like that, okay, whether it cuts down at the x-axis or the y-axis, it will be decreasing linearly. Okay, please refer back to your Form 4 Chapter 1 to understand about the relationship of the graph. Okay, so after that, they will ask you to identify the gradient. Okay, so gradient, 2 marks here. Okay, 2 marks here. So first thing first, you have to draw the triangle. Okay, you have to draw the triangle. As I said before, the triangle must as big as possible. Okay, so, and also you have to include, okay, include the right angle triangle. Okay, so my pattern is I will write down, okay, I will write down the coordinates for the 2 points that I have, I have identified. So these are the 2 coordinates I have identified. Okay, then after that, okay, go back to the calculation. Okay, so this is the calculation. So usually I will ask the students, okay, to write down the formulas. But sad to say that I have marked some of the questions is paper 2. A lot of you don't like to write down the formulas. Actually, if you write down the formulas, you put the values inside, at least you will get 1 mark. Okay, no matter your values are correct or wrong. If you didn't write down the formulas, the markers don't know which formula you are using. So if let's say you put any values, also they won't give you the marks. So please, this formula is very important. Please write it down. Okay, you write down already, then you include your what they call the values inside. Okay, y2 minus y1 or xy is my xy. So then this is your answer with the unit. Remember, gradient has unit. So follow the unit on your graph that you have drawn. So as you know, your formula is y divided by x. So your gradient's value also it will be y divided by x. Okay. I will ask you to write down in -1 like that. But if you write down this method, okay, this format, okay, CM stroke G is also accepted. Okay, is also accepted. Okay, so lastly, as I said, the last question, sometimes they will ask you to predict. Okay, if the rubber band is added, parallel. So what will happen to the extension? So it will decrease. Because if you're adding parallel, the system, the spring system, it will become have a higher spring constant already. So it will be stiffer. So it will harder to extend. That's why the extension will decrease. Okay, so this is how you tackle the marks. Okay, I can give you to let you see another examples. Wait. Okay. Okay, so this is another example, okay, of the Amali questions. Okay, so this is about what do we call as the relationship between inertia and the mass. Okay, so as you can see here, same. The first sentence, they will give you the 2 variables already. So in these variables, they have given you the mass of the processing and the period of the string. So depend on the questions. You see, you read the questions carefully. They have given you the mass of the processing. So as you know, if let's say the one that the previous questions I've given you, the mass of the one that they have given you, the value that they have given you, it will be your MV. The one that they ask you to measure, okay? Like for example here, record the time taken for 10 swings, okay? This will be your responding variable. So over here, okay, you see, okay? This your responding variable is the period of the string. Or if you, let's say you follow the questions, time for 10 oscillations, also it will be accepted. Okay, now here, they ask you to write down the constant variable. Okay, as I said, constant variable parameter, the, what do you call? The measuring instrument cannot be one of your constant variable. So the distance between the one end of the hexablade and the processing can be accepted, or the length of the hexablade. Okay, then you see they have given you very straightforward is the 4 values, not as the previous question. They say that tabulate the value of L and X for each value of the M. So this, they have given you all the values clearly. So here, okay, say table, draw using ruler and pencil. Okay, first draw the table. Second, your first row, okay, will be the unit and the symbol and the unit, symbol and the unit, symbol and the unit, symbol and the unit. Okay, then consistency. Okay, you can see that here, there are some of them, there are 2 decimal places. Some of them, there are 3 decimal places or 4 decimal places. Okay, if let's say, like for example, this question, okay, the T is actually being calculated based on this. Okay, like for example here, okay, you will have okay, anything the value, okay, the readings that involve calculation, okay, you can give it up to 2 decimal place. Okay, why fixed to 2 decimal place? Because it's easier for you to draw your graph. Okay, it's easier for you to draw the graph. So anything that will involve calculation, you round it off into 2 decimal places. Okay, you round it off into 2 decimal places. Okay, so sometimes, okay, they will say, ask you, okay, from here, T, then they ask you to calculate T squared. Okay, here maybe you can make it into 3 or 4 decimal place because it will be increasing your consistency or accuracy when you are calculating the T squared. Okay, in short, okay, if let's say you read through the questions clearly, okay, at the end part, they are asking you to draw a graph based on T square and M. Okay, the one that they ask you to draw, okay, you remain the readings into 2 decimal place. You remain the values into 2 decimal place because it's easier for you to draw the graph later. Okay, so you see here, they ask you to draw the graph T squared against M. So remember which one is your y-axis, which one is your x-axis. So the one before against is your y-axis. The one after against is your x-axis. Okay, so you can see here, okay, I give you another examples of the graph. So this is the graph that I have drawn here. Okay, so if you can see here, okay, I've written something. Okay, you have to remember one thing. Okay, when you are drawing the graph, okay, it's impossible for all the points. Sometimes some of the experiment is impossible for you to get all the points, okay, to connect on the graph. So which means that you have to add the line. So which means that you need to draw a best fit line. But keep your mind, okay, take note that the point that is not connected on the line, okay, the gap between this point to the line must maintain up to 0.5 cm. Okay, the gap must maintain at 0.5 cm. If really you cannot get it, okay, you get it more than 0.5 cm. So you see here. Okay, so you see here, okay? So in short, experiment for physics, you have to understand the concept. Okay, so if let's say the experiment, like for example, Charles' law, okay, the volume increase, the temperature increase. So the value that you get for your temperature must be increasing. Okay, if let's say it is not increasing, sometimes it remains the same, and maybe for the first, second reading or third reading. So what you need to do is that you remember this one. Okay, I hope you understand what am I talking here lah. Okay. Yeah, so these are the, as I said, these are the 7 ticks. Okay, so if let's say you get 6 to 7 ticks on the graph, so it's 3 marks. 4 to 5 ticks is 2 marks. 2 to 3 ticks is 1 mark, and the 0 to 1 ticks is no marks at all. So this is very easy for you to get the marks. So please don't lose it. Okay. Okay, then for this question, they ask you to state the period of oscillation, okay, based on the graph, okay, when the mass is 70 grams. So if you look back the graph here, you can see that, okay, I have drawn a solid line towards the y-axis to identify the d squared. Please must draw the line. Have to draw the line with the arrow at end, okay, to identify the values. So you get from the graph, the d squared is 0.575. So if let's say they want to ask you to find a d, so you just square it to get the answer. Remember, your answer, physics, any calculation, the answer must include units. Okay, must include units. And last one, sometimes the question they will ask you about the precaution. Remember, as I said before, all the questions, okay, the precaution only one. Okay, all the experiment, the precaution that can be used for all the experiment only one. Your eye must be perpendicular to the scale of the reading of any measuring instrument used. For here, they're using a stopwatch to measure the time taken. Okay, so you use that as the measuring instrument to avoid parallax eye. Okay, you remember this. Please, this is very easy to remember only. You remember this, you can easily get 1 mark already. Actually, paper 3 is to help you to get marks. As long as you follow the format, okay, you follow the format, straight, direct, you are able to easily get the 15 marks. Okay? Can I? Okay. So, okay, the last question is, if the hacksaw blade, okay, this is the prediction. Okay, what happened to the gradient? So you use the formula here. Okay, we can see that if let's say higher elasticity is the spring constant, no? Because higher elasticity, which means that it is stiffer. So spring constant and the gradient, it will be inversely proportional. So if let's say higher elasticity, it will decrease. Okay, so this is what that I would like to share with you about the answering technique, okay, for paper 3, okay, physics paper 3. Okay, I hope that you are able to understand what am I saying here. Okay, so and I wish you good luck for your trial SPM physics. Okay, later on I will share the two what we call the questions that I'm sharing here, okay, in WhatsApp group. Okay, you can refer to it. Okay, so good luck and thank you. Bye bye.